When you start off as a new developer, it can feel like there's 1,000 things that you have to know. Databases, a lot of times at a large company, will have somebody dedicated solely to that. But at a small development house, you might be the front end, the back end, the DBA, the tester, the everything. So today I wanted to talk about 5 common mistakes that I see new developers make when they have to make databases for the first time. Now my goal in this video is not to give you a full explanation of everything. My goal is to give you things to look out for and things that you're going to need to research as you're building your database so that you build your platform well, so that it can grow correctly, so that you don't end up with a mess on your hands. The first of those mistakes is using the wrong data type. When we're working with databases, say you want to hold some text. So you might think, right, I'll make a text field. But what you don't know is there's also a varchar field, a car field, and several other types of fields all meant to hold text, depending on what type of text you're trying to store. And while that can seem confusing, another area where you start to get into using the wrong data types is when you're trying to store things like a status or a true or false. I've seen databases where they might store statuses as a character field. Now, they kind of get there where they use a single character for their character field, but they might say, okay, A is for approved, and P is for pending, and D is for deleted, and D is for delayed. Okay, wait, no, we can't use D because we already used D, so Y is for delayed. And you end up with this field in this database full of these full of these letters. Nobody else has any idea what those letters mean. It's not documented everywhere. You have to dig through the code to figure out what the heck do these letters mean. Sometimes you might find yourself thinking, okay, I need some type of true or false field. And I've seen this same strategy where they might use a single car field and they'll say, okay, I'll use a Y or an N to store this data. As you get a little further into this, you realize there's a specific field for a lot of types of data. For instance, a true-false field for SQL Server, you might use a bit field, or for MySQL, you might use a tiny int field. And essentially, what these fields are meant to store is either a 1 or a 0. They take up very little space, they're very fast to index, they're very fast to search, and they serve a very specific purpose, and they do it better than any other type of field in there. As far as text goes, there's multiple different types of fields depending on how much text. Do you know exactly what amount of text you're going to have? Does it fluctuate? Does it need to hold large amounts? There's a lot of different types of fields that you're going to want to know about to find the specific type of field that you want for your data. The second big issue that I see people running into is not normalizing your data. So what does that mean, normalizing your data? Well, let's take this example of statuses. In a database, let's say you have some table that holds some type of object. Let's say it's a request of some kind. And you need to know where in the process of the workflow that request is. So you need some type of status for it. Now, a lot of people might go to that, oh, I'll just use some kind of character to indicate what status is. What you want to do in a situation like this is have a separate field that, if you're going to have a lot of these, you're not necessarily going to name it this, but you're going to name this field statuses. Just pretend you can read my writing. Now, in this statuses field, you're really only going to have 2 columns. An ID field and a name field. Now, as databases get more complex, maybe there's statuses that can be used at certain times, and you might have other values in there. Maybe there's statuses that no longer exist, and you might have an indicator that they're deleted in some way. But you want to have this specific table just for your statuses. Now, why do we do this? Well, one, this name gives us a human readable value to know exactly what those statuses are. But really, the main reason is because in your main table, you will have a status ID field, and it will link to that ID. Well, it will link to that status table. Now, the reason you want this is because, one, that character field is much harder to search than an integer field is. You see, this status ID, let's say you have 4 statuses in here. A value of 1 is active, a value of 2 deleted. Now, in this status ID field, it's going to be an integer field. And so you're either going to have a 1, a 2, a 3, whatever the status is in that field. And so normalizing your data, while it does add a level of complexity, it's going to make your database perform faster, it's going to make it easier to manage, and it's going to make it easier to grow your database. There's a second reason that you normalize your database, and that kind of goes back to using the wrong data types again. For instance, you might think, well, they can have 4 of these things, so I'm going to make a field that is comma separated, and then I'll just keep all the values that they can have in that one field. The problem with this type again is, you're storing the data, but you have no easy way to search or index that data. So in a case like this, let's say we're building a online shopping platform. So you might have an orders table, but then you have an items table. So you have orders for things they purchased. You have an items table for things that are on the shop. But how do you know which items they bought for the order? Well, you're going to create what's called a link table or a join table. And you might have this table called order items. All the letters are there, I promise. And so that's going to have IDs from both of these fields. And it's going to join together because you have what's called a one-to-many relationship here, because you have one order, but it has a whole bunch of items in there. Number 3, not indexing your data. Okay, what is an index? I've used this word several times. So let's say you have a field of users. Now, in this field of users, maybe you have an active flag because maybe they can delete their account, but you don't want to permanently delete everything. You just want to indicate that they are no longer active. So you might have this active field with a true or a false value in it. Not long after I started developing, I started working on this side project for somebody. And pretty soon, this application grew and grew and grew. As the application grew, the speed of it decreased. So size, speed, bad combination. I was reaching out to people. I was a new developer trying to figure out what was going on. I said, my queries have gotten so slow. And he said, well, what does your indexing look like? And I said, my what? Now you have this field you're going to have to search on, because I'm going to only want to pull back active users, or I'm only going to want to pull back inactive users. So I'm going to create an index on this field. Now what an index is, in the most basic of terms, is it's almost like this hidden table that the database creates of just this one value. So when I want to search something, it looks through just this one specific place, and then it goes to where those records are. By putting an index on this one value, when I search my records, it's going to increase my speed dramatically. Without getting into the how and the why, just trust me that indexes are something you're going to need. The fourth thing that you really need to watch out for is how you name your database fields, your database tables, everything about your naming convention. One, you're going to want to have some type of standardization to how you name things. But the more important aspect of that is naming them something that makes sense. Now, A lot of times you might think, okay, well, I have my user table and I need a status ID of some kind. Okay, good. SID, status ID, done. Here's the problem. As you build your application, as your database grows, and as more people come on, somebody's going to look at this and say, what's a SID? I don't understand what the SID field is. What does that stand for? And you might think, well, I want to abbreviate stuff. I want to be as efficient as possible. And so maybe you have a reference number. So you call a field refno. But you know that at the time, but anybody who's worked on a project and come back to it a month, 2 months, 6 months down the line, you're looking at these things, you're thinking, I don't remember what this thing is. I don't remember what it means. You're always better off using a longer name that's easy to tell what it is right away rather than trying to be clever or efficient or creative in some way. Make it obvious, make it simple. And now this fifth one is a little more complicated, but let's face it, databases get complicated real fast. And this is one that can bite you down the road and you don't realize it until it happens, which is actually probably true of most of these things. But there's something in databases known as referential integrity. And that doesn't actually come up until you start normalizing your databases. Okay, so what's referential integrity? Well, let's go back to our orders idea. So I have an orders table. I have an items table. Those are letters, don't worry. I have my order items table. Now, what happens is somebody decides, okay, I don't want to make this order after all. Like maybe you save an order for somebody when they leave the site so that when they come back, all their stuff is still in their shopping cart. So you create this order, you create these items, but obviously you don't want to leave them in there forever. So maybe after a certain amount of time, you delete those orders. Well, if you come in and delete this record out of the orders table, but you don't delete these records out of the order items table that correspond, you have what's called orphan data. And so as you're trying to run reports or as you're trying to query things, you're going to end up with this orphan data that's in your database that might skew your reporting. It can cause a lot of problems in weird ways that you don't necessarily think about when you're creating this. So there are rules that you can apply to a database where you have foreign keys and primary keys. And all that means is the ID on this is my primary key, and it references an order ID in this field. That's my foreign key. So by linking those two and enforcing referential integrity, it makes sure that I don't end up with this orphan data later on in the database that's going to come back to bite. So we just kind of skim the surface of what was there. There's so much to databases. There are people whose entire jobs are DBAs and making it as efficient as possible, making it as fast as possible. You think about the database that a bank must have, or even maybe a social network where they have millions upon millions upon millions of records. They have to optimize these databases. They have to make them as efficient as possible. But you, as a junior developer or a mid-level developer, you may find yourself having to create a database. You're going to want to know enough to create a database that's going to be able to grow with you and have as few things come back to bite you down the road. There's a lot of stuff to watch out for, and these are just a couple of the ones that I knew bit me as a young developer. And so hopefully this helps you along. If you like this video, like and subscribe. Bye.